afternoon to all of you. Today we have magnetic susceptibility experiment. In this experiment, first of all, we have our apparatus, this telescope by which we will see our meniscus. So first of all, what we have to do, we have to adjust uh, this telescope and or we can say focus this telescope on the meniscus, the level of the liquid.
This is actually FeCl3 solution.
FeCl3 paramagnetic solution.
We have to measure its magnetic susceptibility and magnetic moment of Fe3 plus ions.
Yes. So first of all, we need to adjust, you can say focus our telescope to the level, top level of this FeCl3. It will be inverted. So like when you will adjust it, it will be showing upside down, like my finger. As you can see my finger, the level will just look like this. Okay. And after adjustment, you have to measure the readings through this scale. So as you can see here, this is vernier scale and this is main scale. So look closely. Let me give you some. Do we have pen? Yes, I guess so. Okay, so you can see here, this is vernier scale from 0 to 50. 0 to 50, this is vernier scale. This is our main scale. It's in centimeter, 30 centimeter, 40 centimeter, 50 centimeter. And this is our vernier scale. Least count is 0.01 millimeter. So our readings will be like, first of all, let's see if you want to measure the reading. So look closely, our reading, focus it. Yes. So as you can see here, it's just wait, below or on the above 3. I think it's below 3, right? Pause the video, let me see clearly. Okay, so friends, first of all focus here. Yes, as you can see here, it's just above little, just focus one more time. It's not showing clearly. Yes, so it's slightly above 3. In video it is showing below, but in reality when you observe, due to parallax error of camera, but in reality it's slightly above 3. And the vernier scale which is matching is 3 or 2. I know it's showing different in camera, but in reality it's 2 or 3 which is matching. So our reading will be like this. We have to measure reading in centimeters. So our reading will be at, as you can see, it's 30 centimeter. So just above 30 centimeter will be 30 point. Uh, so it's 3 centimeter. Sorry, so sorry for inconvenience. It's 3 centimeter. In millimeter, it's 30, but in centimeter, it's 3. So it's 3 centimeter, and the vernier scale is in millimeter. So I think we should measure first in millimeter, then we should
Then convert in centimeter.
okay, then you should consider 3 centimeter to be as 30 millimeter. So 30 millimeter. Then after that you will match vernier scale which is matching it. So as you can see here, 2 is matching 2 and 3 are exact. Focus one more time. a very good afternoon, a good morning, a good night to all of you. So आ गए आप लोग? पक्का आ गए? इधर देखो, इधर देखो, इधर उधर नहीं, इधर देखो। एग्जाम में इसीलिए पढ़ रहा हूँ, आई नो। सो एक्सपेरिमेंट नंबर 4, हमें क्या करना है? टू फाइंड आउट द मैग्नेटिक ससेप्टिबिलिटी ऑफ FeCl3 सॉल्यूशन ऑफ गिवन स्ट्रेंथ FeCl3 सॉल्यूशन की मैग्नेटिक ससेप्टिबिलिटी हमें फाइंड करनी है। ओके, एंड सेकेंड हमें करना है टू फाइंड आउट द मैग्नेटिक मोमेंट। टू थिंग्स, मैग्नेटिक ससेप्टिबिलिटी एंड मैग्नेटिक मोमेंट। ओके, दीज आर द फॉर्मूलाज। मैग्नेटिक ससेप्टिबिलिटी 2 रो जी एच बाई एच स्क्वायर, रो 3 साई के टी और हाफ एन बी स्क्वायर। नाउ अब आप ये सब रीड कर लीजिए, इसमें कौन सी चीज़ क्या है। रो डेंसिटी ऑफ सॉल्यूशन, जी एक्सेलरेशन ड्यू टू ग्रेविटी, ए एरिया ऑफ क्रॉस सेक्शन। So you can read this from there. Okay. Now, these are the calculation which you have to show in the exam. See carefully all the calculation. One more time. And one more thing, you have to take 1.5 gram per centimeter cube density solution in 30 ml water, but the total volume of the water will be 40 ml. So when you will take volume of total solution, then it will be 40 ml. 30 ml due to this and 30 gram. So it's 30 gram, it will
10 ml.
increase the volume 10 ml. Okay, so don't get confused in there. Okay, so these are all the, you can see the table. Current is this, magnetic moment, sorry, magnetic field is this, h square of magnetic field in Gauss. You have to take readings in Gauss. Then capillaries reading, I will tell you how we will take these readings here from capillary. R naught is the reading when our magnetic field is when our current is zero. Okay, at current zero, at magnetic field is 0.05, our R naught reading is this. Okay, and then we will minus whole reading from R naught like this. 2.6 minus this reading will be this. 2.648 minus 2.634 will be this. You have to minus final reading minus R naught is equal to this. Okay, so now let me tell you how we have to do the experiment. So this is our FeCl3 solution. You have to take 40 ml solution. It will be given to you in the examination. Then
It is going from this pipe
this
in
pipe
this
to
capillary tube.
in this capillary, you can see the level
This is the
of zoom it,
meniscus of the capillary tube,
meniscus of the capillary. Okay,
and these are two solenoids,
these are the magnets in between which each is capillary tube is
electromagnet.
placed. Okay, now let me on the power supply
This is
here.
our traveling
This is the
telescope.
best moment of e colorful movies in the. Okay,
Hmm.
so this is our telescope. You have to set telescope by using this knob to the in meniscus. Like by using this knob you can set the telescope for the best focus. And how you have to set? Actually this capillary tube will look like inverted, like my finger is inverted. You will be thinking it will look like this, the level of water, but it will be inverted like this. So you have to set on the just top of where you find easy to the top level to observe. You will set out your main focus to the top of that. Okay, level water, FeCl3 level. Okay, and after setting, I am repeating once again, in capillary tube the water level will look like this, inverted. So you have to set your focus, it will look like curve, like this curve. So you have to set on the top of that level. On the top of that level you have to set your focus after the telescope, so that you can observe the increase in the level of the liquid. Okay, and this is our scale by which we will measure our reading. So how you have to measure? You will rotate.
This is our main scale.
This is our main scale. Okay, I will tell. First of all, let me tell
Hmm.
like how we will. You will rotate this knob like this to take readings.
This is move the scale up and down.
This will move the scale like first you will set by moving this scale, and by adjusting this focus like this, you will set your meniscus to the top level of the liquid. Okay, on the between where you can find easy. After setting, you will take your current zero here. Like first you will take your current zero here, then you will set, and then you will measure the R naught here. Okay, so how you will measure R naught? You can see here two scales. One is in centimeter, 3 centimeter, 4 centimeter, 5 centimeter, and here is vernier scale in millimeter. The least count of the vernier scale is 0.01 millimeter. So how we will take our readings? As you can see here, right now it is showing 33.5 3.5 centimeter. So we will convert it into millimeter to, because our vernier scale is given in millimeter. So 3.5 centimeter, how much it will be in millimeter? Tell me.
35.
Multiplied by 10, so 35 millimeter, right? 35 millimeter. And additional zero point 0.5 is given there. You can see additional zero point 0.5. Yes, our zero is just above the zero point 0.5. Let me focus it. Okay, yes, our zero is slightly above the zero point 0.5, so we will consider this zero point 0.5 also. So it will be 35.5 millimeter.
Mm.
Once again I'm repeating, it's in centimeter, so you have to multiply by 10 to measure it in millimeter. So it will be
0.5 millimeter.
35.5 millimeter. Okay, because zero point 0.5 factor, I am zooming it again. You can see here just above. uh, Wait, yes, you can see here. Where is my pen so I can see you clearly? uh, as you can see here, where is zero? Yes, our zero is here. So the big line, it's showing 35, but the zero is just slightly above this one small line.
35.5.
So this small line and the distance between this small line and this big line is zero point 0.5 millimeter. So it's zero point 0.5 millimeter, so the total reading will be 35.5. Now we will measure our vernier scale reading to add it on. Okay, so in vernier scale, how we will measure? We will see which line is best matching, which vernier line, which these lines, vernier lines, these vernier lines best matches with our main scale lines. So as we can see here, you can observe
This one.
here you can say point 0.1 is matching.
Mm.
Let's take point 0.1 is matching. So point 0.1 is matching with our vernier scale. So it's 10. In vernier scale, it's not point 0.1, it's 10. Don't get confused due to point. It's 10 readings. 0 to 1, it's 10 scales. We have to consider is whole 10. So our 10 will be multiplied to our least count. 10 multiplied by least count, how it will be? It will be 0 0.1, right? 0 0.1, yeah, 0 0.1. And our old reading was how much? 35.5. And our vernier scale is 10 scale here multiplied by least count
0.01 millimeter.
0.01. So I am
It
showing
will
you
be
the calculation.
35.51 millimeters.
Let me show you the calculation here. Mm, Here our main scale reading was main scale reading main scale reading it was 35.5 millimeter. 35.5 millimeter. This zero point 0.5 comes due to the length between the small lines. Small lines. Due to the length between the big line and small lines. I'm observing in focus mode clear. This point factor. Okay. So now vernier scale reading is equal to 10 scale on. We have observed 10 is matching with vernier scale multiplied by least count. Our least count in this is also in millimeter. This is also in millimeter. Our least count was 10.0, so it will be 0.1 millimeter. And this reading is also in millimeter. So first reading, our first reading will be 35.5 plus vernier scale reading 0.10. 30.550 plus 0. So we will add it. Okay, so our main reading was this 35.50 and vernier scale reading is 0.10. So we will add it. So our first reading will be this in millimeter. But dear my friends, since our calculation is in centimeter, so we have to convert it into main reading into centimeter. So we have to divide it by millimeter, divide by 10. We are going from small to big, so we will divide
3.56 centimeter.
3.560 centimeter. This is our first reading at zero current. So zero current, it will be what? Say with me, are not.
Hmm.
Are not. So as you can see, our first reading earlier in our experiment we got 2.634, but right now I'm getting 3.560 centimeter. Now next step, what I will do, uh, like it's in the given here table, I have to increase my current to zero point 0.5. So I will increase my current to zero point 0.5. And let me tell you one more thing, slowly increase, because if you increase it very drastically, then it will show error due to polarization. So slowly increase, and it's 0.48, so just it's zero point 0.5, don't worry about it, it's almost zero point 0.5, just consider it zero point 0.5. Now our let me tell you what will happen in here. Our water level will increase, sorry, FSL3 level will go down. So we have to, what we have to do, like earlier it was like here, earlier it was here, but due to increment it will slightly go below, just below. So we have to, again what we have to do, by this knob, by this knob we have to tight it, we have to
By looking in the telescope,
by looking into telescope we will tight.
is it visible?
It's very hard to say, no it's not, we are trying but it's not visible. We will show you. Okay, so here we will show you how meniscus is increasing. Okay, so dear my friend, I'm going to increase the current, and you can see that bright thing is our water level, means FeCl3 level. So as I will increase the level, you will see it's moving down. You can see it's moving down. I'm decreasing, it's moving up. So you have to, for example, earlier my first reading R naught was this. So now I will okay, let me show you again. Show the meniscus, show the meniscus. Okay, uh, it's not a yes right now. Okay, so I am increasing my current with 100. Earlier it was 50, I am increasing now 100. So as you can see, it's move a bit below. Let me increase more so you can see more. It's yes, so you can see it's moved below. So now what I have to do, I will rotate this knob to match the level. So you can see, again look carefully, I will rotate this knob to match the level. So I'm going to rotate and you will observe the change. Okay, so you can see I'm rotating the knob. It's not focused, yes, right now it's focused. So I'm rotating the, it's, you have to move anti-clockwise to match the, so you can see now its level is almost uh, matching with our, almost, yes. So I have matched below level. So like this you have to move. How I have moved, now I'm moving in here on the top, and I will show you how I have rotated. So okay, on the top, now I will show you here how I have rotated. So I have rotated like this, and it will be matched here. Uh, you can see here it's approximately matched here. So like this you have to rotate, and after rotation your scale will be moved upward. Your scale, for example, I'm showing how it is moving upward. You can see I'm rotating and it's moving. Please show the people like how I'm rotating and how it's moving. You can see here I am rotating, it's anti-clockwise and it's moving. I am tightening it so it's moving downward, but I have to you have to rotate anti-clockwise to move. After rotation we have to take second reading. So right now, earlier our reading was like something, let me tell you, it's like something 3.5, nearly here, something 3.5. So let's say after rotation our reading is something, it's top, it can't go beyond it. Okay, let's see, after rotation is our reading is this. Okay, so mm, for example, it's not, wait, okay.
Similarly, we will just take the readings.
Then earlier our reading was 35 point something. So after the change, it will slightly change. Like I'm moving it forward. You can see the change. I'm moving 36, but it's not 36. It will be 35 point something. You can see here the change in my readings. I'm showing you the readings, so by which you will understand like how much it will change. Mm, you can see here in my readings, it is changing in millimeter, so it will be very minute change. 0.005. It's in centimeter, but it's changing in the millimeter range. Okay, so here focus it again. So now for taking readings, see here. Now I am again telling you how we have to take readings. So consider right now it's still in between of 35. It's 30 centimeter. So it's 35. Again I'm
It
showing
is
it
above
again.
35.5.
So it's you can see it's 30 centimeter. It's 35 centimeter. Sorry, 35 millimeter. Thir- it's 3 to 4 centimeter, but in millimeter it will be 30 to 40 millimeter. So it's 35 millimeter, and the point 0.5 is there 35.5 millimeter.
Now we have to
So
take best match of vernier.
it's just slightly above 35.5 millimeter. Okay, zero point 0.5 is a small box. 35.5 0.5 is this small box, and 35 is big line. Okay, 35 is this big line, and zero point 0.5 is this small box. So it's 35.5 millimeter. Now we have to match vernier. So for vernier, let's see which line is matching best. So I think here we can say from the hair top, it's, let's say,
This one.
I know we have many, let's say 30 is matching best. So we have 30 scales. So from here we can see 0, 10, 20, 30. Our 30 is matching best with main scale. So our vernier scale will be 30 multiplied by our least count. 30 multiplied by our least count, what it will be? It will be zero point 0.3. And now I am again showing the calculation. Main scale was 35.5
Five
plus
point.
vernier scale is 30 multiplied by least count 0.01. So it's 35.5 plus 0.30. 35.80. Second reading is this. Like this we have to take reading. It's far away from this. It will be very minute change here.
Convert in centimeter.
We have to convert it in centimeter also. So 35.80 divided by, it's in millimeter. It's in millimeter. It's the whole reading is but we have to do calculation in centimeter. So 35.5 millimeter divided by 10, it will be 3.580 centimeter. Like this we have to take readings. Okay. Okay, so let me tell you again how we will adjust our telescope to fix the uh,
Meniscus of
meniscus
FCL
level.
resolution.
FSL3 level solution we have to fix.
Now let's see the working of all the knobs of this traveling microscope.
Yes. So this knob we have for readings, as I have shown earlier. You will rotate it for
This is for
fine
fine
rotation,
adjustment of height.
height.
And this back, we have one knob here. This is for, this will lose the this
This will
vernier.
vernier for the adjustment of like big adjustment. Your water, where is your water level? You have to face the telescope here in front of your water. So this is big adjustment. So first of all, you have to place your telescope in front of water level. Then you have to tight it. After
Then we have to
tightening it,
adjust it with fine adjustment screw.
and make sure your telescope is tight, because otherwise if it will be loose, then it will show it as in reading. After tightening it, we have two knobs here, one knobs, and here this is one knob. Two knobs here, one knob is here. So
This
this
knob is for focusing on the meniscus.
focusing on the missile, and this is for the horizontal adjusting, like horizontal how it's adjusting. So as I'm
Rotate it.
rotating it, it will go this side, left side for
Turn
anti-clockwise,
it off.
and for clockwise it will go down, right this side. So horizontally you have to match the level which is best for you, and after the horizontal adjustment you have to focus it by this knob. Okay. That's all. I hope you understood all the things. Thank you so much. So, very good afternoon to all of you. Complete is another set of our magnetic susceptibility. So, in this, the only difference we have is this box, this big box for providing current, and that otherwise rest of the thing are the same for the other experiment. But let me tell you one more thing. This is very this is showing very fine increment in the level of the meniscus of FeCl3 solution. So if you get a chance to get like magnetic susceptibility experiment, then please choose this one because this is very fine showing this is very fine adjustment. Okay, this is showing very fine adjustment. So this is the current providing setup. So how you have to on this setup, I am going to tell you. First of all, we have
Let's
to
turn
on
it
the
on.
power supply, the as usual. Then after that, it will be off. The knob will be off, but you have to turn it on. So you will on. You can see that the knob is on right now. Okay. So the knob is on right now. Right now, this is showing our current scale. How current is going to increase. Okay. So I'm going to increase the level of the current. You will show from here. So we have to increase it from the on the scale. You have the range of 1 to 5. You can see here 1 to 5. But we have to increase the current only till 2.5. On the point 5 gap, we have to take only 5 readings. So for that, we have to take on point 5 gap till 2.5. So I'm going to increase the current. You can see here I'm increasing. So my needle is increasing. First reading is point 0.5, so we have to stop at point 0.5 and we have to take reading at point 0.5. Second reading is will be at point 0.1, 1 ampere. So I will stop at 1 ampere and I will take reading. Third reading will be at 1.5 ampere, then 2 ampere. Then similarly, last reading will be at 2.5 ampere. So my final reading will be at 2.5 ampere and I have to take that reading and I have to note down on the copy. Rest of the thing will be same earlier like it was for the old. And as you can see here, the
Take a
minis,
look at the meniscus.
it's right now. I think it's not visible, but it's showing very fine. By eyes, it is showing very fine. So you will observe very fine
Cross wire
increment.
is not visible.
Don't worry.
Yes, now it's visible.
Yes.
Actually,
So don't worry about it. Rest of the thing will be similar like other experiment which I have explained in the other videos. So don't worry about it. That's okay. You have to take readings similar to that. You have same knobs here like this knob, this knob, this knob. I have explained the function earlier. This is for vertical horizontal arrangement. This is for focusing and this is for fine adjustment for taking readings. So
everything is same. Least
everything.
count is also same.
Least count is also same.
But table is a bit different.
David
Magnetic
is
field.
magnetic field is a little bit different. You can take the screenshot and thank you बाद में बोलिए. You're welcome.